Math Blast 30. I can identify prime and composite numbers. Look at the numbers below. Shade each number that is prime. So for the number 13, I know that 1 and 13 gives me 13. If those were the only factors of 13, the number is prime because a prime number has exactly 2 factors. If I can come up with any other factors for 13, then the number would be composite because composite numbers have more than 2 factors. For 13, 1 and 13 are the only 2 factors, so I will shade in the box representing it as a prime number. 85. 1 times 85 gives me 85. But a divisibility rule for numbers that end in 5 tells me that 5 is another factor of 85. And that's all I have to do is determine at least one more factor that other than 1 and the number itself, and I have now proven that number to be composite. 60. 1 times 60 gives me 60. And a divisibility rule says any number that ends in 0 has factors of 5 and 10 as well. And so I'll just note one other example would be 10. 10 is a factor of 60, so 60 is composite rather than prime. 16. 1 times 16 gives me 16. Because 16 is an even number, I know that 2 is also a factor for 16. So I'm going to note that as one more example of a factor, giving 16 more than 2 factors, which means it's a composite number. 19. 1 times 19 gives me 19. And those are the only 2 factors for 19. So I'm going to shade in the box here for 19, representing it as a prime number. 2. 1 times 2 gives me 2. And those are the only 2 factors for 2. So 2 is also a prime number. Fill in the chart below with 4 different composite numbers that are between 30 and 40. Keep in mind, composite numbers are the numbers that have more than 2 factors. So I'm going to use even numbers between 30 and 40 because I know each of those numbers would have 1 and the number itself as factors, but because they will be even numbers, they'll also have 2 as a factor. So I'm going to jot down 32, 34, 36, and 38. Those are not the only ones. I could say, hey, maybe 5. A number ending in 5 has a factor of 5, so 35 would have been a real easy example there. All right, let's go ahead and go down to the next box. I can round to the nearest specified whole number. Round 285,364 to the nearest 1,000. Show your work. I'm going to show my work using a vertical number line. And since I'm rounding to the nearest 1,000, I'm going to ask myself, if thousands is my greatest unit, how many total thousands make up my number? 285 thousands. I can write that in standard form as 285,000. And I might note that here in unit form because I ask myself then, if I had one more 1,000, what would be at the top of my vertical number line? And that would be 286 thousands. In standard form, I can write that as 286,000. The midpoint, the number that lies directly between 285,000 and 286,000, is going to be 285,000, what's at the bottom of my number line, and 5 in the next unit, so 500s. 285,500. Now, I need to find where my given number, 285,364, lies on the vertical number line. And I know it's going to be below the 285,500. Since it lies below the midpoint, it is going to round down to 285,000. Any number that lies below the midpoint rounds down. Numbers that are at the midpoint or above would round up. I can understand decimal fractions. Write each fraction in decimal notation and each decimal in fraction notation. Then locate each number on the number line. So I'm going to do the first part. I'm going to write each fraction in decimal notation. 9/10 would be 0.9. 4/10 would be 0.4. And now the decimal needs to be written in fraction notation. So 0.1 is read as 1/10, and I can write that as a fraction. Now I'm going to locate each number on the number line. And noting that my three numbers are in tenths, the units I will be using on my number line are tenths. I will start at 0 here, and I will represent 1 at the end of the number line here. With my units being tenths, I want my number line to be broken into 10 equal parts. All right, now I can represent 9 tenths on my number line. I know that 1 is 10 tenths, and so I'm going to put 9 tenths at the tick mark right before my 1 whole. And underneath of that, I'm going to write that in decimal notation, 0.9. Notice those are the same point on the number line, so I don't want to write 9 tenths beside my 9 tenths as a fraction. I want to write the fractions either above or below the number line and the decimals in the other place, okay, above or below. So 4 tenths, I know that 0 is 0 tenths. And then I would have 1 tenth, 2 tenths, 3 tenths, 4 tenths here. And I'm going to write 4 tenths as a fraction above and 4 tenths as a decimal right below the same location on the number line. And 1 tenth would be 1 unit past the 0. And so I will note that as 1 tenth there. That's my unit fraction. And 0.1 is the decimal version of that. Luke says the following number sentence is true. Anaya says it is false. Who is correct and why? So 1 tenth is less than 9 tenths is the statement that is there. And so Luke would be correct because 1 tenth is less than 9 tenths. I'm going to state that there. Luke is correct. 1 tenth is less than 9 tenths. And there's some reasons I could use. I might say that 1 tenth is left of 9 tenths on the number line and left is less on our number line. I might also note that 1 tenth is a unit fraction and 1 tenth times 9. It takes 9 groups of 1 tenth to make 9 tenths. Okay. Let's go to our next page there. I can determine the perimeter and area of a rectangle. Determine the perimeter and area of the rectangle below. So for perimeter, I'm going to underline this key little word in there, rim. Perimeter is the distance around the figure, and so I'm looking at the rim of the figure. I'm going to start at one point and make my way all the way around the figure. 3 centimeters plus 8 centimeters plus this side is opposite the 3 centimeter side, so they're the same. And this top side would be opposite our bottom side of 8 centimeters, so it is also 8 centimeters. And now I can add all of those dimensions there. I can say 3 centimeters plus 8 centimeters plus 3 centimeters plus 8 centimeters gives me the entire perimeter, all the way around the rim of the figure. And I know that's 22 centimeters. So the perimeter is equal to 22 centimeters. The area is the square units that it takes to cover the two-dimensional surface there. And we first learned area back in 3rd grade where we had to count the square units inside of our rectangle. And then we began tiling rectangles. And so with a side that's measuring 3 centimeters, I could make 3 columns. Or I'm sorry, 3 rows. And in this case, the side that's measuring 8 centimeters, I would make 8 columns. And then I could add up all of those squares that are in there. I could count all of them. But I also then moved to learn that area for any rectangle is the length times the width. That would give me the number of squares that is created inside of that box, that rectangle. And so I'm going to say the area is 3 centimeters times 8 centimeters. And that's 24 centimeters squared. And so the area is equal to 24 centimeters squared. I understand angles are measured with reference to a 360-degree circle with its center at the common endpoint of 2 rays. A circle measures 360 degrees. If the circle were divided into 3 equal parts, What would be the angle measure of each part? And explain how you know. So I'm going to make a center point here because when we make our sectors, our pieces in the circle, we want them to be of equal size and they need to come off of that center point. And so I'm going to draw 3 equal sectors. And now I know that if my whole circle is 360 degrees, I want to equally share that among 3 sectors or 3 parts there. 360 divided by 3 is going to be 120 degrees in each sector. Okay. And then I can determine the measurements of missing angles. Determine the measure of angle ABD. Well, an angle is created from 2 rays that are connected there. So BA is a ray and BD is a ray, and they are connected or meet at point B, which is the vertex of the angle. So here is the vertex of my angle, and this ray BA is my initial ray lining up with 0, and as ray BD opens up, it's getting larger and larger. The angle's getting larger and larger. So we want to start with 0 and work our way in an increasing manner, which means I'm going to be using my exterior numbers on the compass here, or on the protractor. Compass is for circles, but this is a protractor. And so here we go. I'm measuring, I get to 10, 20, 30, and not quite to 40. I see this point here is 35, and so I'm going to say that this measures 38 degrees. Right about 38 degrees, give or take once, okay. We just want to be as close as we can here. All right, that's all for today, math friends.